What's up, Algebra 1? We just started topic 3 of Module 2, and this is all about systems of equations, systems of possibly inequalities later. And so the idea is that we are going to be trying to figure out where a lot of these are crossing, or where their x or y intercepts are. But this first one really only deals with one equation, so let's jump into it. Basically, if you read the question, Mr. Johansson's given 50 question multiple choice tests. And if you get a question right, it's worth 2 points. But if you miss a question, it is half a point deducted. And then it says a student needs to earn 80 points on the test. So here's the idea. You're getting 2 points every time one is correct. But then it's deducting 1.5 points for every time you are incorrect. And we're trying to get this to be an 80. Okay? So a few points that would work. Maybe you got 40 correct. 40 times 2 would be 80, and then you didn't miss any. So there you go. 40 correct answers, you got 80 points. Or maybe you missed 4, and so if you are losing a half a point 4 times, you're losing 2 points. And so that's why if you do 2 times 41, you're getting 82. So you kind of have to offset your incorrect by getting more correct to stay on that 80. Or potentially maybe you missed 8, but that meant you had to get 42 correct. These are all points that work in the equation. Now part B says determine the x and y intercepts. And so to do that, I want to basically plug in 0 for the opposite letter. So I'll start with saying 2c equals 80. Basically just for a moment plugging in 0 for I. So 1/2 times 0 is 0. And so I'm going to divide by 2 to figure out one of my intercepts would be here at 40. The next thing is to find the y-intercept, and that is to plug in 0 for the opposite letter. So 2 times 0 would be 0, and I'm left with negative 1/2 of the incorrect equals 80. Okay, so now I'm going to multiply by negative 2, and that actually gives me negative 160. So my graph is actually off a little bit because this point is really way down here. And that would be at negative 160. Okay. All right. So these are basically the ideas of like how many you could miss on if you had no correct versus if you had none correct. What are your scores? And so obviously you're going to lose a ton of points if you missed every single question, and so that means that you have lost a ton of possible points. So the next question is saying that Wesley owns a dairy farm, and in the morning it takes him 0.3 hours to set up for milking the cows, but once he's set it up, he only takes 0.2 hours to milk each cow by hand. So that is my first equation. Kind of living in the general form or the slope-intercept form, I am seeing that 0.2 per cow, and I'm also starting with a 0.3 hour setup. So I don't want both of those to have variables, only the one that seems to happen more than once. And that is the 0.2, because I'm going to spend 0.2 hours per cow. Now the other one, it says he's thinking about buying this machine. It takes a little bit longer to set up, but in terms of how long it takes to milk each cow, much faster. So that is my second equation. 0.05x plus 0.4. And so part A is achieved by setting up these two equations. Now part B says for me to graph that. So I have graphed each one, just kind of a general sketch. The first one is starting at 0.3, and 0.2 is really rise over run of 1/5. So that's why it's very, it's not very steep. It's kind of shallow here, going up 1/5, up 1/5. The other one is starting a little higher at 0.4, but it's even less steep because 0.05 is really 1/20. So it's like I'm rising 1, running 20, rise 1, running 20. And I'm looking for this point of intersection. So that would ultimately tell me where their times are the same. How many cows does it take for them to really calculate the same amount of time? So it says, let's estimate that point of intersection. And so I did something a little better. I went ahead and graphed it. So in y equals, I have gone ahead and put both of these equations. And I manipulated the window just a little bit because I don't really need a lot of x or really a lot of y here. So I went ahead and graphed it, and so now I have my two lines crossing, and I've kind of scrolled around until I can see it's somewhere in here around 0.6 and 0.4. And what's great about the graphing calculator is if you press second trace, number 5 is intersect, and then I can force it to tell me the exact moment in time where they cross. So it looks like that's 0.6 repeated for x and 0.43 repeated for y. So that is my solution. This point right here is 0.6 repeated and 0.43 repeated. So the next part is asking, well, hey, what if you wanted to solve that by hand? So let's go ahead and verify what that would look like by hand by setting both of these equal to each other, and that's what I did right here. So let's start by putting the x's together and also putting the constants together. And ultimately when you divide, you do find 2/3, that's your 0.6 repeated. And if you'll go ahead and plug that value in to one of the equations, you can get 0.43 repeated. Okay? So the idea here is that you have one solution, they cross at one particular point, so there is a consistent system here. Okay, so let's talk about what the answer means. We kind of got to go back into the problem a little bit. X represents how many cows you had to milk, and the Y is how much time it took. And so when we're talking about this point down here, this is like how many cows it would take to milk for them to be the same amount of time. And so this is, you really got to think about this. That means that that machine is so fast that it's really going to be faster to hook up that machine that's going to do it for you than to do it the other way. Because plugging in 1, if you just say I want to milk 1 cow, 0.2 times 1 would be 0.2. If you add 0.3, basically 1 cow takes 0.5 of an hour. It takes about, 0.5 of an hour, half an hour. However, if you plug 1 into the second one, 0.05 times 1 plus 0.04, 1 cow in the other one actually takes 0.45. So their intersection is really in the middle of milking 1 cow, and so that machine is really worth it, and Wesley should consider purchasing one. It's going to save him a ton of time. I'm going to come back to the stretch, if you will, so just keep on going with me. The review here, we're trying to solve a few compound inequalities. So in the very first one, I'm trying to get x by itself in the middle. So I start by adding 10 to all sides. And once you add 10 to both sides, we now see the range of x values that makes this true, anywhere between 20 to 35. Next, we have an OR problem, and so we need to solve each one individually. And so I start by adding 11, dividing by 2, and I find out that any value less than 3 is a solution. Remember that if it's OR equal, you will fill the dot in, versus if it's only less than or only greater than, it's an open circle. Let me move the laptop down a little bit. This other one happens at at -9. This one's actually interesting. I had to pause for a second. This one's interesting because even though it's an OR problem, you really end up getting a bunch of different possible answers now that I really look at it. So for this, any value greater than -9 and any value less than 3. So the truth is that or goes forever in the opposite direction. And so for this one, really, any value of x will solve the first part or the second part. Now part A, if I'm talking about graphing this one is truly trapped between 20 and 35. I want it open at 20 because there is no or equal sign. I want to fill this one in because it does have an equal sign and any value trapped in between them. Let's go to number 2. I didn't work this entire problem, but I wanted to get you started a little bit. First thing I noticed is that there's distribution, but you're really only distributing a 1. So I really didn't do anything except get rid of the parenthesis. And once I get rid of the parenthesis, I noticed that I could go ahead and put 4 plus 3 together to get 7. But now I need to continue the process trying to get x by itself. And so let's see how well you do with that, and we'll check your work in class. Number 3, consider the equation 2/5 x minus 2y, and they want us to write this in general form. General form is that idea of slope-intercept form. Basically get the output by itself, get y equals, and then we'll identify the slope and the y-intercept. So the fact that we have this division of 5 is really kind of holding us back a little bit. So the first thing I did is start by multiplying 5 throughout the whole thing. Now the first time you do it, this one would cancel just to give you the 2x there. However, I don't want to mark through that 5 because that suggests that I don't keep multiplying. So I do multiply 5 times negative 2 to get negative 10. I do multiply 5 times 14 to get 70. I then begin subtracting the 2x to the other side. And then I divide by negative 10. And this is our slope value. Our slope is 1/5. Slope is designated with the letter M a lot of times. It's Latin for the word in Latin that represents the idea of an angle or slope of terrain. And this negative 7, well, this number is your y-intercept. 0, negative 7 is where that graph will begin. Determine the linear equation. So they want us to write a regression. Regression means we need to go into a calculator that has regression and run some type of linear regression model. And so I went ahead and put in list 1 and list 2, 1, 2, 5, 7, 10, 12, 11, 30, 39, and 50. And I went ahead and got the equation from the calculator. So I think for the second one, I'll just model that process. So I'm going to go into the calculator. I'm going to press Stat. I'm going to go to Edit. And I'm going to go up to the name, clear Enter, so that I can put in new data. 12, 10, 8, 5, and 0. And then the other one is 3, 9, 11, 14, and 0. So now when I run number 4, I'm going to get an equation. So it looks like I have y equals 0.28x. And then I also have a b of 5.4. Now, importantly enough, you need to catch this r value is 0.23. This is very weak. That means that this equation does not model this very closely. However, this one is very strong. So in terms of which equation is the better fit, this one is a way better fit because it has a stronger correlation coefficient. Okay? I'm going to do one more. You can forget the stretch for now. We'll talk about it in class. But I'm going to talk about number 3. It says whether or not this is consistent or inconsistent. So I take a moment to try to get y by itself. I add 3x over. I divide by 4, and I get my equation. Trying to get y by itself in the second one. Add 12 over. And divide by 16. And one thing that I notice is that these two lines are parallel. If they're parallel, that means they're going to have no solution. So for this one, I'm going to say it has an inconsistent system. So go ahead and try the other ones, and we'll check your work tomorrow. Thank you so much for watching the video.